Hello there, fellow math enthusiasts. Mrs. Delzati here. Today we're doing a quick recap of Unit 4, our unit on transformations. So we had 4 different transformations, with the first one being our translation. And keep in mind that a translation, it shifted an object right, left, up, or down. Congruency was preserved, and so was orientation. So if I take a look at number 1, I want to find the coordinates of A prime and B prime. After the translation, xy is taken to x minus 3, y plus 4. Now keep in mind, because this is a minus 3, that means we are going 3 to the left. And since this is a plus 4, we're going 4 up. That means each of our points, we're going to go ahead. We're going to count 3 left, 4 up. Let's do it. 1, 2, 3 to the left, 1, 2, 3, 4 up. And here is where A prime is going to be. That coordinate is negative 1, 7. Make sure you put your parentheses around it because that makes it an ordered pair. For B, 1, 2, 3 to the left, 1, 2, 3, 4 up. Here is B prime. And we're going to see that B prime's coordinate is 4, 5. And then we can go ahead, we can connect those dots. Now, we also had a reflection. A reflection went ahead and it flipped an object over a given line. Congruency was preserved, but orientation was not preserved. So with number 2 here, what I would like to do is I'd like to find the coordinates of A prime and B prime after reflecting over the x-axis. So I'm going to draw in my line of reflection here on the x-axis. And to reflect, all we have to do is count how far away is that point from the line of reflection. If I start with A, it is 1, 2, 3, 4, 5, 6 up, which means I've got to go 6 down. 1, 2, 3, 4, 5, 6 down, and I have A prime. My new coordinate here is 3, negative 6. To go ahead and to find B prime, well, we'll do the exact same thing. We'll start at the line and we'll count 1, 2, 3, 4 up. So we count 1, 2, 3, 4 down. Here's B prime, and my coordinate is 8, negative 4. Anything that's above the line goes below. Anything that's below goes above. If we were reflecting over a vertical line, if it was on the right side, it would go to the left. And if it was on the left side, it would go to the right. Now, my next transformation is a rotation. When we rotate something, we turn an object over a given, I don't want to say over a given line, I want to say about a given point. So I'm going to change this out here. We're turning an object around a given point. And typically that point is our origin. All right, we'll see again that congruency is preserved, but orientation is not preserved. So the rules of rotation, keep in mind we had 2 different sets. My class focused on this first one here on the left side. If we were rotating 90 degrees or 270 degrees in either direction, we would flip the x and the y coordinate and then make sure that our signs were the appropriate sign based on whatever quadrant it was in. If we were rotating 180 degrees in either direction, we would keep x and y in the same order, and then again make sure that our signs were appropriate for whatever quadrant we were going to be in. So with number 3, I want to find the coordinates of A prime and B prime after rotating 90 degrees clockwise about the origin. Well, 90 degrees clockwise means I'm going to be moving 1 quadrant. Clockwise means I'm going ahead, I'm heading in that direction. So all of my points that I'm going to be plotting are going to end up in quadrant 4. I know quadrant 4 has the signs positive x and then negative y. We're going to keep that in mind when we do the rotation. So our original coordinates for A, we have 4, 8. And our original coordinates for B, we have 6, 1. Since I'm doing a 90-degree rotation, I've got to switch the x and the y coordinate. So instead of 4, 8, it now becomes 8, 4. I see that my x coordinate has to be positive, my y coordinate has to be negative, which is why a prime is 8, negative 4. For b, again, I switched the coordinates. It was 6, 1, and now it becomes 1, 6. The x coordinate has to be positive, the y coordinate has to be negative, which is why b prime is 1, negative 6. So a prime is 8, negative 4, and b prime is 1, negative 6. And again, I can go ahead, connect those dots. We've gone ahead, we have rotated that 90 degrees about the origin. Now, the last transformation that we have is our dilation. With a dilation, we either enlarge or reduce the size of an object. So as I'm taking a look at a prime and b prime, that's what I want to figure out. After I dilate it, xy is to 2x, 2y. I'm going to start by writing down a's original coordinate, which is 1, 2, and b's original coordinate, which is 4, 3. Since I am dilating it 2x, 2y, all that means that I am doing is I am taking both of those coordinates and I'm multiplying it by 2. So 1 times 2 gives me 2. 2 times 2 gives me 4. And that's my a prime, is 2, 4. B, which was 4, 3, 4 times 2 is 8. 3 times 2 will go ahead and give me 6. So b prime, I have 8, 6. All right, the scale factor is what we went ahead and we multiplied by there. So our scale factor is 2. And is this an enlargement or is this a reduction? Well, it got bigger, so it's an enlargement. Our scale factor is also bigger than 1, which goes ahead and verifies that, yes, we do have an enlargement here. So this was a quick recap on our transformations. We had translations, reflections, rotations, and dilations. Del Zadi is done for today. I will see you in class.